Hello and welcome. In this video, we are going to discuss how to set up the Open Automation Software General Purpose Input and Output Communication Driver, which is built into the OAS platform. This enables OAS to communicate to the GPIO pins on a Raspberry Pi 4 device. You can view a written tutorial on this on our website at www.openautomationsoftware.com under Support, Knowledge Base, Data Sources, Raspberry Pi GPIO. First, we need to download and install OAS on our Raspberry Pi 4. There is an article and a video on how to do this on our knowledge base under Support, Knowledge Base, Getting Started with OAS, Quick Start, Raspberry Pi Installation. Or you can follow the Linux installation guide on our knowledge base under Support, Knowledge Base, Getting Started with OAS, Quick Start, Linux Installation. The OAS for Linux download contains a script to easily set up the OAS engine to run under the OAS user account. You can opt to run it under a different account as long as that account has root permissions if you prefer. Next, we need to set up access to the GPIO mem, the GPIO driver, for the user account the OAS service is running under. To do this, we need to log in as a root user and add a rules file in the etc udev rules.d directory. Once you've logged in, type cd/etc/udev/rules.d/. Then we need to create a new file. You can do this with the Linux Nano text editor. Enter sudo space nano space oas-gpio.rules. You can cut and paste this from the Getting Started Raspberry Pi GPIO tutorial in our knowledge base. Save and exit, and then we need to reboot the system. To do that, type sudo space reboot. That completes the setup. Now we are going to use the OAS Configure app to configure the pins. From a Windows system, start the Configure OAS application from the program group Open Automation Software. Select Configure Tags from the top menu. In the Network Node drop-down box, enter the IP address of the Raspberry Pi device and click Select. Here are the demo tags that have been installed with the software. Right-click on the tags group at the top of the tree and choose Add Group. I'm going to call mine GPIO, but you can call it whatever you'd like. Then select your new group in the tree and right-click on it to select Add Tag. I'm going to call this Pin 5. Again, you can call it whatever you'd like. Since the pins are digital, we need to change the data type to Boolean. Next, we change the data source in the drop-down list to GPIO. Now we need to specify the pin mode as either input or output. A pin has to be one or the other. It can't be both. I will set this as an input pin. Input pins also need to have a polling rate specified. I will set this one to 0.01 seconds. Next, click the Save Changes button, and you can see the value of the pin comes in now as true. To configure more tags, you have three options. You can add them manually one at a time, as we just did. You can use the CSV import and export buttons on the toolbar to bulk edit and load them with a CSV editor, such as Excel. Or you can programmatically define tags using the opcsystems.net component with the tag CSV import and driver interfaces CSV import methods, or with the OAS REST API. There is information on how to do these things in our knowledge base under Data Sources, Tags, CSV Export and Import, and Data Sources, Tags Programmatic Interface. The next thing we are going to do is save the changes we made to our tag configuration file by clicking Save on the toolbar. We give the file a new name, or we can leave it as it is. A prompt will appear asking us if we want to set the file as the default tag configuration to load on startup. I will say yes. This will have our new tag configuration load if the system is restarted. This setting can be found here under Configure Options. Again, we need to choose the Raspberry Pi service. Under the Default Files tab, here under Tag Configuration. The configuration is now complete. You can now read or write to your new pins, depending on the pin mode. You can transfer data from input pins to any of the data sources that you have a driver set up for, including Modbus, Allen Bradley, Siemens, MQTT client and MQTT broker, OPC UA server and client, Azure or AWS. You can also generate alarms, log alarms to a database including SQL Server, Oracle, Access, MySQL, CSV, InfluxDB, and others. You can send alarm notifications via email or text. You can create a .NET desktop application or web application to read and write to the pins. You can create a web user interface to read and write to the pins. To learn more about all of the things you can do with the GPIO pins and open automation software, please visit our website at www.openautomationsoftware.com.